Okay, this problem is asking for us to find the rule of the geometric sequence. In order to have that, we need to know the first term and we need to know the common ratio, right? Sorry, I should move that down just a smidge. So we need to know the first term and we need to know the common ratio if we're going to write the rule for this geometric sequence. We talked about how geometric sequences, they have this common ratio, this number that you continually multiply by. If we set this problem up one way, we could say we don't know the first, second, or third term, but we know that the fourth term is 8/9. We don't know the fifth, sixth, or seventh term, but we do know that this term is 128 over 729. So this is what we know written out in this sequence format. In order to find the first term and the common ratio with these pieces of information, we could look at this and say, well, if this is the fourth term, in order to get the fifth term, I'd have to multiply this times r. And then I'd have that, and I'd multiply it times r to get this term. And then I'd have that term and multiply it times r to get that term. And then I'd have that term and multiply it times r to get to here. And we talked about this when we were first talking about geometric sequences. So what we're saying is, if I know the fourth term and I multiply that by the common ratio 4 times, r times r times r times r, I should get the 8th term, right? And when we talked about this with, when we were first talking about geometric sequences, if I add these two numbers together, I should get that number. So with this information, if I have 8/9 for my fourth term, times r to the 4th power, and that gets me 128 over 729, I can start to solve for r here, okay? So I can multiply by the reciprocal here to isolate the exponential term. So we have r to the 4th power equals, let's see, what is that? On the top, I think I'm going to get 16, and on the bottom, I think I'm going to get 81. Pretty sure that works out right. I don't know, I did that in my head. 81, yeah, and that's a 1 and a 6. Yep, okay, so here we go. So we have r to the 4th is equal to 16 over 81. If we want to solve this, right, how do we get r? If r is raised to the 4th power, how do we get r by itself? We take the 4th root, right? We can take the 4th root of this as well. All right, now on the calculator, once we have r, we're going to have r equals. To take the 4th root of this, you should probably take 16 over 81 to the 1/4 power. And if you do that, you're going to get 2/3. So now we know what the common ratio is. Okay, so we know part of this sequence formula, but since I need to know the first term, we can come back up here to the front. Now we know the common ratio is 2/3, right? So we can take the 4th term and divide by 2/3, divide by 2/3, divide by 2/3 to get us all the way back here to the beginning. There's nothing wrong with that, okay? I know that if I have the first term and I take the common ratio to the 3rd power, I should get the 4th term, right? Same scenario I set up here. As long as these two values add up to this value, this is a true statement for geometric sequences, okay? So if I want to know, let's stay with this. Sorry, I don't want things to get too jumbled. But if I stay with this, I want to know what the first term is. If I cube 2/3, I get 8 over 27, and that's equal to 8/9. The 4th term is 8/9. If I multiply by this, if I multiply by the reciprocal of this on both sides, 27 over 8, I'm going to get a value of 3. So I have my first term, I have my common ratio. Therefore, the rule for this geometric sequence would be 3 times 2/3 to the n-1 power. We write the first term in front, we write the common ratio with a base of n-1. Okay, so the bottom line with this problem is in any geometric sequence, we have this special relationship where if we know the term number, or we can set up any equation where the term number and the power of r, the sum of those values equals this term number here.